Fourth one is quaternary amine. This is a salt actually. Why? Because you observe here what happened. Two charges. It is salt actually, right? So again, I am explaining this one. The definition: amines are derivatives of ammonia. Amines are what? Nothing but the derivatives of ammonia. This is ammonia. How we call derivatives of ammonia? Just by replacing one hydrogen. See, one hydrogen replaced with an alkyl group. You can replace with aryl also. Aryl means nothing but benzene. Okay, you can replace this R, otherwise benzene group. We get primary, secondary, tertiary. Finally, what happens? We get quaternary salts here. This is about the classification of amines actually, isn't it? Now, when you observe in this case, nitrogen will have what type of hybridization? All the cases, the nitrogen is having sp3 hybridization only and pyramidal shape only, isn't it? So whenever if you observe primary, secondary, tertiary, the hybridization of nitrogen will be sp3 hybridization. The shape will be what here? Pyramidal shape here, isn't it? Now the fourth orbital of nitrogen in all amines contains unshared lone pair. See, just now we discussed this one. You see, observe this one. When you observe this one, three bond pairs are there, one lone pair, isn't it? You are having a one lone pair. In all the case, you are going to observe one unshared pair of electron. Unshared pair of electron is nothing but what we can call lone pair of electron, except what? Quaternary salt, which is actually what? A salt actually, right? Next, we'll see this structure. Now, when you observe, this is the nitrogen. This is the nitrogen, right? Now here you are getting methyl group here. Here you are having a methyl group here. And here you are having a methyl group here. Now here you are having a lone pair of electron. This is the lone pair of electron. Now what they are saying actually here, this is having what hybridization beta? sp. Because how many pairs are there here? Electron pairs 1, 2, 3, 4 electron, including lone pair, 4 electron pairs. If you have, the hybridization will be sp3 hybridization. So generally the bond angle of ammonia will be 107 degrees. Ammonia bond angle is 107 degrees. It is also near to what? 107 degrees only. This structure actually, right? Next, classification and nomenclature. Let me discuss now. So I told you how many types generally we are having: primary, secondary, tertiary, and quaternary. But quaternary generally what happened because addition of what? That alkyl halide. That is also we can take. So generally it is having three classifications are there. Primary, this is the primary way. RNH2 primary, dialkylamine secondary, trialkylamine is called tertiary amine actually, isn't it? Now, how to give nomenclatures here? How to give the nomenclatures? First of all, I will make here what happened. Instead of reading all these statements, let me take an example. Okay, let me take an example. I will take. So for that, what happened? We will take root word. This is the root word. Already you know root word means what? Number of carbons. This is the root word. This is primary suffix. Always will be what here? Ane. This is the secondary suffix. Will be what? Amine. Now we'll take some examples to explain these things. We'll take some examples. Is it visible? That slide is visible better to everyone?
Yes, sir.
Yes, sir.
Slide is visible to everyone. Are you there? Or not?
Yes, sir.
Yes, sir.
Yes. This slide is visible to me.
Yes, sir.
Yes, sir.
Yes, sir.
My voice is audible?
Yes, sir.
Yes, sir.
Yes, sir.
My voice is audible better.
Yes,
Yes,
sir.
sir.
Yes.
Voice is audible?
Yes, sir.
Yes, sir.
Your voice is not coming, I think. One thing, what I will just reconnect this one. I will just reconnect. Now it is okay. Your voice, my voice is audible now.
Yes, sir.
Yes, sir.
Right. Okay. Now, actually, we are discussing that nomenclature. No? Let me see again that nomenclature. To move to what again that nomenclature now. Right. Now we'll see this slide now. Nomenclature. Amines. Now, first of all, I have taken a simple amine here. Now you have to see that I common name. Let me see all of you. Anybody, what is the common name is possible? Anybody? What will be?
Ethylamine.
Ethylamine.
Very good. Ethyl and amine. Ethyl amine. This is the common name, right? Now let me see now your IUPAC name. How to give the IUPAC name? Root word, primary suffix, secondary suffix. Root word, eth, because you are having two carbons are there. Because I am having two carbons, you have to call this one what here? Eth. Then primary suffix definitely will be ane because single bond is there, and amine. So it will be what? Eth, ane, amine. Ethanamine we can call this one, isn't it? Ethanamine. Eth plus ane plus what happened? Amine. Ethanamine we can call this one, right? Will you do what next one? This will be definitely what happened? N-propylamine because propyl is a common name and this propyl is having state chain. Therefore, N for what state chain? N-propylamine, it's a common name. IUPAC name, anybody?
Propanamine.
Propanamine, propanamine, very good. One more thing here, one amine also we have to use. Why? Because if we get like this, for example, if we get like this, what? This will be CH, right? This will be what? CH, right? Now, in this case, it is also what? Propanamine only, correct or not? It is also what? Propanamine only, but we have to give numbering in this case. 1, 2, 3. Propan 2 amine. It will be propan 2. In the previous case, it is called what? Propan 1 amine because 1, 2, 3. Propanamine only. It is also what? Propane amine. But amine is on which position? First carbon. So 1 amine it is. Now this will be what actually? Propane amine. But propanamine will be called propan 2 amine because on second carbon you are having what? Amine. What will be the IUPAC common name? Isopropylamine, isn't it? It is called isopropylamine. Correct or not? Because it looks like this: CH3, CH, NH2, and what happens? CH3. Now, second carbon is having what beta? Second carbon is having methyl group. Therefore, it can be called iso. Open 2
So
amine.
can we call it secondary?
Secondary. See beta. I told you in just now. If you have 2 hydrogens, 1 alkyl group, it is primary, right? When you have what happened, 2 alkyl groups and 1 hydrogen, that is called, isn't it, secondary. And 3 alkyl groups, that is called what, tertiary. So here, based on carbon, you can't say secondary. For amines, remember beta, for amines, you cannot see carbon for getting primary, secondary, tertiary. You have to see what actually nitrogen you have to see. If nitrogen bonded to 1 carbon, or if nitrogen having 2 hydrogens, that will be primary amine only. If nitrogen bonded to 2 carbons, you see, nitrogen bonded to 2 carbons are having only 1 hydrogen, that will be secondary. If nitrogen bonded to 3 carbon, that will be what, here, tertiary. So completely different here. Okay, so based upon the carbon, you can't say secondary.
Yes, sir.
You see this one, NH2 you have to see. NH2 means when you get nitrogen 2 hydrogens, actually nitrogen have only 3 bonds, possibility 3 bonds. In that case, if you put 2 hydrogens, remaining will be alkyl group, correct? So let me see this one, we'll get nomenclatures. Now we get a different type of nomenclature, in that all doubts will be clarified. This one will be better, primary, secondary or tertiary better?
Secondary.
Secondary. Why? Because nitrogen bonded to 2 carbons here. Nitrogen bonded to 2 carbons. Otherwise, nitrogen has only single hydrogen. So definitely it is a secondary amine. It is. Now nomenclature will be given differently. Okay. Now common name very simple. This part is ethyl part. This part is ethyl part, and this part is what? Methyl part. So we can call alphabetical order ethyl methyl amine. What we can call? Ethyl methyl amine. Now how to give IUPAC nomenclature? In this case, you have to remember like this. N R R dash. For example, if it is having more carbons, if it is just imagine this is having more carbons, like ethyl group, more carbons it is. This can be called as alkane. This can be called as alkane. And this will be called alkyl because it is having less number of alkyl. N alkyl, we can call N alkyl. So nomenclature will be N alkyl alkane. Now you see here. Now which is having less number of carbons beta? Methyl or ethyl? Which is having less number of?
Methyl.
Methyl. Therefore I can call N methyl because methyl is having less number of carbons. N methyl. Next. You have to see root word for this one because it's already completed. This one is already completed. So you have to see the root word for this one. How many carbons are there? 2 carbons. Therefore, eth. And remaining is common. N methyl ethane it is called. N methyl ethane, isn't it? N methyl ethane. After that, what happened? What about amine here? This amine. This one you have to call as amine. Therefore, you can call amine. N methyl ethanamine. So you can call this one what? N alkyl alkanamine. Right? For example, we'll take one more example. So, no. This one will take. One more example will take. CH3, CH2, N, CH2, CH2, CH3 I have taken. Right? This is called what? Ethyl propyl amine. Correct? Ethyl propyl. This part is ethyl part. And this part is what? Propyl part. So you can call ethyl propyl amine. Having one hydrogen. Having one hydrogen. Also one hydrogen is there. Now, which is smaller part? Ethyl propyl. Which is smaller part beta?
Ethyl.
So N-ethyl you have to call. N-ethyl you have to call. So this is completed. This part is completed. Next, alkanamine. Here how many carbons are there in the long chain here? 3 carbons are there. So called prop. 3 carbons are in. Then what happened? This part is called what? Amine. So called amine. The nomenclature will be N-ethyl propanamine. Now, for example, if you have like this CH3, CH2, N, CH2, CH3. Both are having same number of carbons. Diethylamine. Common name is called diethylamine, isn't it? But IUPAC nomenclature, both are having same, no? So in that case, anyone you can select. N-ethyl, isn't it? N-ethyl, isn't it? Next, what happened? Ethanamine. Ethanamine. Finished. In this way, you can give nomenclatures for other compounds of secondary compounds. Understood here? Any doubts you're having in this secondary amine?
No, sir.
Right. We'll move to what now? Tertiary amine. Now this is a tertiary amine because nitrogen bonded to 3 carbons, therefore tertiary amine it is. Common name is trimethylamine. Simply we can 3 methyl groups are there. Trimethylamine we can call. This is the common name. And for this one, how to give the nomenclature here? So in this case, what happened? N-alkyl. Next, what happened? N-alkyl. Alkanamine. In this way, we can give it. Now, there are 3 substances are there. 1, 2, 3. So these are the 1, 2. This one will be what? The substance which is having what? More number of carbons. More carbons if we have, we can select this one. Now you observe here what? N-methyl. Right? Next, one more N-methyl. And for example, just if it is having longest carbons, we just assume like that. So what will be? Methanamine. But N-methyl, both are same. No, you can write N, N dimethyl, methanamine. In this way, we can give, right? So you will get here like this, N, N dimethyl, methanamine. We'll take one more example like this, CH3, isn't it? N, CH2, CS3. Then what happens? CH2, CS3 uptake. Now you have different numbers. Now common name will be what? N-ethyl. This part is ethyl. This part is methyl. And this part is propyl. We can call this one ethyl, methyl, propyl, amine. Common name. Ethyl, methyl, propyl, amine. Common name is very simple. Ethyl, methyl, propyl, amine. According to alphabetical order. But IUPAC nomenclature, how to give this? Now we have to select first of all longest one. This is the longest one. It should be alkanamine. And these two will be substituent. Now one is N-methyl, other will be N-ethyl. So write down N-ethyl. Next comma, N-methyl. Sometimes dash they may not be used. N-ethyl, N-methyl. And this will be alkanamine. How many carbons are there in alkanamine? 3 carbons. Pro, amine. So it is called N-ethyl, N-methyl, propanamine like this. Now if you want practice, you can take like this. You take here what happened, you take here what methyl group here. You take here what happened, propyl group like that. And here you can take what? Butyl group like that. You will get practice. Okay. 1 carbon, 3 carbons, 4 carbons you take like that. This will be what? Definitely alkanamine. This will be what? N-methyl, N-propyl. Alkanamine means what happened? Butanamine. So you have to give nomenclature. You take as a practice this one. Understood everyone?
Yes, sir.
Nomenclatures only simple only will get, not lengthy you don't get. Now this will be definitely, just now I told you this no.
Sir,
Yes, better. Bolo better.
sir, in the previous slide, I want to ask a question.
Come on, tell me. Too fast.
Sir, in the above reaction, can we replace propyl and ethyl and the nomenclature will be same?
Ebo means what better? Ebo means what?
In this N-ethyl, N-methyl propanamine, can we replace propyl and ethyl and we can get same nomenclature?
Propyl and ethyl. You are replacing what better? Tell me here. I am writing here. Tell me what you are writing here. Left side what you.
Sir, in place of propyl, ethyl, and in place of ethyl, propyl.
Now leave it that one. Now here what do you want to write? Left side. What I am writing. Is it visible for you?
Yes, sir.
Left side what do you want to write? Tell me.
So methyl only.
Right. Next right side what do you want to write?
Propyl.
CH2, CH2, CH3. Downside, what you want, right?
Ethyl.
CH2, CH3. Yeah. Tell me what your doubt now. In this case,
The nomenclature will be same.
you are comparing this one, right? You are comparing this one and this
Yes,
one.
sir.
Now, what you are finding difference in this one? Is there any differences there between these two? Are you finding any differences there between these two? What difference you are
No,
finding?
sir.
Nothing is finding. For example, I am writing like you just imagine. I am writing this one. Is it visible for you better? Whatever I am writing?
Yes, sir.
Now, if I put this methyl group, I am putting on above direction, right? If I put what happened, this methyl on downward direction, like this. Any difference you get between these two? Or you find any difference here? No difference.
No, sir.
So this is called isopropyl, sorry, isobutane. It is also called isobutane. Otherwise, it is called 2-methyl propane only. So that means what I mean to say is that you don't see that whether it is left side or right side. The longest chain rule you have to consider. This is having what? 3 carbons. So it is called alkanamine. It is having 3 carbons. It is called what? Alkanamine. Alkanamine is nothing but propanamine. It is called propanamine. It is called propanamine. And this is called N-methyl, N-ethyl. This is called N-methyl, N-ethyl. I am saying what? Longest chain you have to follow. Wherever you get more carbons, that can be selected as alkanamine. Here 3 carbons are there, propanamine. 2 carbons, less, no? Call this one N-ethyl. Less carbons when you compare to this one, N-methyl. Understood?
Yes, sir.
Now this is what just now you see. Now if you have any doubts, it will be clarified now. You see, don't see that left right like that. See that this is having what? More carbons. Now it is called what here? Alkanamine. Alkanamine. Right? Now how many carbons are there? 4 carbons. 4 means what I have to see? Butanamine. Butanamine it is. And this will be what? N-ethyl. And this will be what? N-ethyl. Now what I can call this? N comma N diethyl butanamine. Common name will be diethyl butylamine. Diethyl butylamine, isn't it? Diethyl butylamine. See, diethyl butylamine. NN we don't use in the common name. Diethyl butylamine. After this, what happened? IUPAC nomenclature. N comma N diethyl. You see, N comma N diethyl. N comma N diethyl. Here we don't use N comma N. Remember it is. It is only diethyl butylamine. Now, N comma N diethyl butanamine. But here also, this nitrogen bonded on first carbon. Therefore, you can call butanamine. For example, the same structure I am writing like this: C2H5 N C2H5. Now here what I am writing here, CH, CH2, CH3, CH3. Now what will be the nomenclature? It is also called what? N comma N diethyl butanamine. But the numbering we have to start from where here? Now it is called what? N comma N diethyl, isn't it? Butan 2-amine. That means whenever if we get a longest chain, the numbering we have to do this one. In the previous case, we are not doing any numbering because when you take 2 carbons, what happened? No problem for us. When you get more number of carbons, what happened? The numbering we need to do compulsory. Understood here? Any doubts you are having regarding this one? Giving numbering 2 and 1 we got? Any doubts?
No, sir.
No, sir.
Now this is something what happened alkene here. This is what you have to give numbering in this way. Amines are what? More priority than the double bond. So it will be what here? Propene 1-amine. Propene 1-amine, isn't it? Propene 1-amine, isn't it? Propene 1-amine. Here 2 no need to give. Why? Because if it is 1, definitely it will be 2 here. Understood here? Propene 1-amine you can call. No need to call propene 2-1-amine. Why? Because if it is 1, double bond you can't place here only. No, you can place here only. So you can call prop 2-1-amine or propene 1-amine also. We can. And allyl amine you can call generally this part. Generally CH2 double bond CH and CH2. This is called what? Allyl. This substituent is called what? Allyl. So we can give allyl nomenclatures. Now this is useful in the polymers, but polymer is not there, so leave it this one. Hexane 1, 2, you can write like this: NH2, CH2, 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 CH2. How many completed? CH2, NH2. Now here numbering 1, 2, 3, 4, 5, 6. So 6 carbons are there. Hex, A, and first position amine, 6th position amine, 1, 6 diamine it is, isn't it? Hexane 1, 6 diamine or hexamethylene diamine. It will be in the polymers topic, but polymers are not there, so leave it. So next we'll give something what happened, aromatic nomenclatures. This is called what? Aniline. Aniline we can call, or benzene amine. Therefore, benjamine we can also call. But most of 100% we'll use aniline only. Even IUPAC nomenclature also we can use aniline. Okay, aniline is the nomenclature generally. Now it is called what? Generally IUPAC nomenclature. If we go for this one, 1, 2. Therefore, 2-methyl aniline, isn't it? 2-methyl aniline we can call this one. 2-methyl aniline. Now you can also call like this also, 2-methyl aniline. Toluidine, because it is toluene, no. This is called what? Toluene. You know this one? It is called what? Toluene, right? Now, amine group is also there. Therefore, you are called ortho position. This for this position is ortho position. Orthotoluidine also we can call this one. Orthotoluidine. Or what happened? I told you no. 2-methyl aniline or what? 2-amino toluene. Actually, 2-amino toluene, nobody call this one. Generally, they will call what actually? Leave it this one. Generally, they call what? 2-methyl aniline only they will call. 2-methyl aniline is a correct nomenclature. Isn't it? Nobody will use like this. 2-methyl aniline. Right? Next, remember this one. Toluidine. When you get toluidine beta? Amine and methyl. Can anybody say what is para-toluidine? What is para-toluidine? It looks. Where I have to keep methyl group beta?
CH3 on para
Here
position.
is
Opposite to
CH3, opposite to NH3. If you pet, what happened? It is para-toluidine. The toluidine means what happened? Benzene. What is the meaning of toluidine? Benzene plus amine plus CH3. This is called what? Toluidine, isn't it? This is called what? Toluidine. Toluidine means what? Benzene, amine, methyl, collectively called toluidine. And if these two are put adjacent, they are called what? Ortho, like this. They are called ortho. If you put here what happened, it's called meta. If you put here what happened? Like. Now this is called what? Anybody? IUPAC nomenclature, numbering from starting from bromine or amine?
amine.
1, 2, 3, 4. 4-bromoaniline. The nomenclature will be called 4-bromoaniline. 4-bromoaniline. Aniline also called as what here? Aniline also called benjamine. You can use benjamine also. In the place of aniline, you can use what? Benjamine, because aniline are benjamine. But in your examinations, what happened? Textbook, most 99.9% they give aniline only. So 4-bromoaniline, also called para-bromoaniline, also we can call this one. And this is given what? Tertiary amine or not this one? You see, nitrogen bonded to how many carbons beta? Here 2 carbons, here 1 carbon. According to the benzene also containing carbon only, no. And no hydrogens. Definitely it will be what? Tertiary amine only. Now IUPAC nomenclature will be N, N dimethyl benjamine, isn't it? N, N dimethyl benjamine we can call this one. See? N, N dimethyl benjamine, isn't it? Benzene amine or benjamine also you can call as benjamine. Okay. This is about the nomenclature. N, N dimethyl aniline. This is a common name actually. This is the IUPAC. Okay. You have to practice these because you will get now when you're doing the chemical reactions. You know, you will get all these things. All these things we get generally. Now, can you classify these elements into primary, secondary, tertiary? Is it possible? First one is primary. Second, tell me about first one.
Primary.
Primary, because 2 hydrogens are there, definitely you can call primary. Otherwise, nitrogen bonded to only 1 carbon here. And second one will be?
Tertiary.
Tertiary it is, because no hydrogens are there. Tertiary it is. This one will be?
Primary.
Most of them, what they do, they see this one. They see this one, they say what a carbon bonded to two carbons, say it is what secondary, they say. No, it is not secondary. You have to see nitrogen. So it is what primary. This one will be what?
Secondary.
This way we can identify. Primary, secondary, easily we can identify. So these things, for example, given this molecular formula C4H11N. Okay, how many types of isomers we may write here by using C4H11? How many different type of isomers we can write by using C4H11N? Let me see this one. Okay, right. Now, first of all, I take 4 carbons straight line like this. 4 carbons like this. This is primary amine, correct? H2, 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 H3. Primary amine it is. Now take next to what happened, like another primary amine I am taking like this. CH3, CH2, NH2. In this way also we can make here primary amine. Can you make one more primary amine? Possible? Is it possible one more primary amine? Possible or not? Yes.
Yes, sir.
One more primary amine. This is the one more primary amine. So primary. So primary total I can make 3 structures. Primary I can make total 3 structures. Now let me take secondary amine now. Secondary amine like this. CH3, N, H, CH2, CH2, CH3. So again, say molecular formula must be same beta. Molecular formula should be same. This will be secondary. One more I can make like this. CH3, NH, CH2, not CH2, CH, CH3. It is also secondary amine. What is the name? Anybody? What is the name of this one? This
Methyl propane 2 amine.
This one is N-methyl propan 2 amine, 1 amine. This one is N-methyl propan 2 amine, right? So secondary amines I got like one more secondary amine. Let me take CH3, CH2, N, CH2, CH3 hydrogen. This is the one more secondary amine. Can you get say one more? I got 3 here. One more you can't get here. Next one, let me see here. Tertiary amine. CH3, N, CH3, CH3, and here you put CH2, CH3. Tertiary amine it is. Right? One more is possible. One more is possible. No, these are the amines we are going to get. Let me see this one here. How many amines you are getting? Now they are saying what happened. Write the structures of different isomeric amines corresponding with the formula C4H10. Write the IUPAC moments. Write the types of isomers exhibited by the different pairs of amine. How many they are getting? 8 isomers they are getting. 8 means here how many got here? 3, 6, 7. One more if you want, we can do one more. CH3, CH2, CH3, NH2, CH3, CH3. 1 methyl, 1, 3, C1. Here you can make one more possible CH2, CH3. This we got, right? Butane 1 amine. Just stop this. Okay, Butane 1 amine also we can get like this. No, sorry, I've forgotten one more thing. Okay, one more I have forgotten. I will write that one. We got 7 actually, no? 8th one I will write here. 8th one, that is also primary amine. I will write that 8th one also. We got 7, the 8th one I will write. That will be what? This one. I'll show that. It will be like CH3, CH2, CH, CH3, NH2. This will be the another primary. Primary amine, how many are getting here? 4 you are getting. 4. 4 plus 3, 3 plus 1 is equal to 8 you are getting. This is the primary amine, but propan, so butane 2 amine. Butane 2 amine. Therefore, we are getting how many here? Let me see this. 8 we are getting. Total we got 8. Now this is called butane 1 amine. This is called butane isobutyl amine, otherwise 2-methyl propan 1 amine. This also be written. And C, this also be written. Butane 2 amine. Next one. This also we are written. Tertiary butylamine, primary amine only, but tertiary butylamine, not this. Methyl ethanamine. These are all we got actually. And finally, one more. This will be the how many we got here? 8 isomers we got. Right? What type of isomerism? Again, I will show you all these structures. First structure, second structure, right? Butane 1 amine, 2-methyl propan 1 amine. Butane 2 amine. 2-methyl propan 2 amine. All these are actually what? Primary amines. Total we got 4 primary amines. Secondary amine is also secondary amine. Okay. Secondary is also secondary. N-ethyl ethanamine, N-methyl propanamine. One more secondary we get in the next slide. One more secondary. This is the secondary one. Secondary, how many you are getting here? 3. And tertiary, how many you got here? Only 1. Total what happened? 8 isomers you got actually, right? Now, what type of isomers are exhibited by the amines here? Chain isomers, already we written this one. Chain isomers means how do you get chain isomers here? How do you get chain isomers? I will write this one. CH3, CH2, 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 NH2. This is the chain having what? 4 carbons, butanamine. Butanamine. Right? Now one more I am writing here. CH3, CH3, CH2, NH2. This is called butanamine. What do butanamine? Butane 1 amine. Right? Butane 1 amine. Now this chain is containing how many beta? 3 carbons. 3 carbons. This is called what? 1, 2. 2-methyl, 2-methyl, propan, 1 amine. 2-methyl propan 1 amine. One more also we can write here. CH3, this one. And CH3, NH2. But here what is happening here, when you write this one, the chain isomer having 3 carbons, here also this is having 3 carbons. Now these two are not called chain isomers. These two are not called chain isomers. But these two are called what? Chain isomers. Because here you are having 4 carbons. Here in the chain you are having how many carbons beta? 3 carbons. So this is about chain isomerism. Right? Next we can write positional isomers. Positional isomers means I can write like this. CH3, CH2, CH2, NH2. This is called what? 1 propanamine or propan 1 amine. Propan 1 amine. Now if I write like this CH3, CH3, NH2. What is the name of this beta? The name of this one will be, anybody? This one. The name of this one. Are you there?
Propan 2 amine.
Propan 2 amine. So propan 1 amine, propan 2 amine will have same chain length. The chain length must be same here. In chain isomers, chain length will be different. In position isomer, chain will be same, but position of that functional group will be different. The position of functional group is 1 amine. The position of functional group will be 2 amine. So now it is called position isomers. You got examples here.
Sir, can we call them as metamers?
Metamers will be different beta. Metamers will not call this one. Metamers will be different. I will explain. Don't get hurry. I will explain after this. We'll get here. It is called position isomers only. Don't call this one metamers, isn't it? For primary amines, you don't get the metamers. Remember this one. When you are writing the primary amines, you do not get the metamers. You will get what actually? Positional isomers. But when you write the secondary amines, definitely will get the metamers. So for positional isomers, it will get in the primary amines, right? Next is the metamers here. Functional isomers means all primary, secondary, tertiary amines are functional isomers. Isn't it? For example, if I write what happened, something like CH3, CH2, CH2, NH2. Right? One more I'm writing. CH3, NH, CH2, CH3. One more I'm writing. CH3, N, CH3, and all are having what the molecular formula? C3, H3579, H9N. This is the molecular formula for all these. One is primary, other is secondary, tertiary. Now these are what actually functional isomers. They are called what? Functional isomers. Now what is functional isomers beta here? In this case, for amines, molecular formula is same, but they are exhibiting primary, secondary, tertiary. Therefore, they are called functional isomers. Understood here? Functional isomerism, everyone?
Yes, sir.
Next, we see metamerism. Let me see what happened. Metamerism. Metamerism means what happened. For example, if I take what happened like this: CH2, CH3, CH2, CH3. Now here, how many carbons? 2 carbons. Here, 2 carbons are there around the second remaining. I can also write this with same molecular formula in this way also. CH3, NH, CH2, CH2, CH3. Here, how many carbons are there? 1 carbon. Here, how many carbons are there? 3 carbons. Now, 2 carbons, 2 carbons. Either side, what happened? The number of carbons are different. Either side, the alkane chain is different. Therefore, these two are called what? Metamers. So, metamerism exhibited by just secondary amine. You can write one tertiary also same lines by just changing the number of carbons in either sides. Tertiary also we can. But mostly what happened, we'll take for secondary. But tertiary also what happened, isn't it? You put what happened, 2 carbon, 1 carbon, something, what happened, 3 carbons. I can change this one, 2 nitrogen here, 2 carbon, something. Here also what 2 carbon. And here what happened, 2 carbon like that. So that is the reason what happened. We'll get here also metamerisms. Right? Understood metamerism, everyone? Right? So next, this is about the chapter. That means, about classification, everything like that. Now let me see this textbook. What we discussed here, everything, structure of amine we discussed. This one, primary, secondary, tertiary, nomenclatures also we completed. These are the nomenclatures which is given in the text box. No, we completed already this one. We already completed this one. Which one? Ethylamine, N-propylamine, everything. You have to practice this one now. Today's homework is what? You have to practice this one. Today homework is you have to practice this box. Otherwise, what happens when we get chemical reactions? No, it will be very difficult for us. This also we completed. This is already we completed, and this one also we completed. C4H11 just now we completed up to here. Just now we completed up to here. Now what you have to do? Practice primary, secondary, tertiary amines. It looks very simple, but need to practice this. So practice this 13.2 question and write IUPAC names for all the isomers. Right? Tomorrow we'll see what preparation methods. Preparation of amines here. All these preparations tomorrow we'll see here. Preparation methods will complete tomorrow. And you have up to only what? Amines only. We don't have the diazonium salt. So our syllabus is only up to here only. Definitely we'll get question here only, up to only here only. We'll discuss up to only. This is not there in the syllabus, right? Now yesterday I think I have said you one question is there. I have to discuss next. I will say I said yesterday that the question will be discussed tomorrow. You see that one actually. One question is there in the carboxylic acid. Let me discuss that one. This takes only 2 minutes only.
Sir, after amines, which chapter is there?
Yes, beta. Yes.
After amines, which chapter is there?
After amines, we have completed that biomolecules in PDF format. So again, I have to discuss about biomolecules, surface chemistry, and solutions. 3 more chapters are there. And we have given target that up to by 20th, we need to finish the syllabus. By 20th, we can finish that No problem.
Yes, sir.
That is the reason I am taking daily class, because we have instructed that we have to compulsory complete the syllabus by what? 20th only. Okay, tomorrow I will see. It takes some time, no, to search everything. Tomorrow we'll discuss that one. Okay, we'll discuss tomorrow that one. And you have any doubts now? The remaining one we'll discuss tomorrow. No problem. Already it is 9 o'clock, getting 9. We'll discuss tomorrow. Now I will take the attendance now. All of you. Amruta. Next, Anupama. Dhruv. Bhuneshwari. Deva. Hariom Patil. Manjusha. Neha M. Nidhi. Nikita K. Nikita K tomorrow, yesterday absent. Nikita. Nikita T. Nishant. Devashish. Prajna. Pranali. Radhika. Rani. Samiksha. Samrin. Samruddhi. Shivani. Shreya Paushe. Shreya. Sneha. Swapnali. Tejas. Vaishnavi. Belgaonkar. Vaishnavi K. Vanita. Varsha. Venkatesh. Vinayak. How many are absent today? Priyanshu. पाटिल आदर्श. पाटिल आदर्श एब्सेंट है ना? बाद में ये नहीं बोलना है कि मैं हूं ये. पाटिल आदर्श एब्सेंट. पार्थ. पार्थ एब्सेंट. Parth absent.
Sir, I am present.
Your name is now displayed. Previous it is not there, your name.
Sir, it got disconnected.
Patil Adarsh also there? Patil Adarsh. No. Priyanshu also absent. He is absenting. I will call today. Rohini. Rohini. Absent. Kiran absent. Vaishnavi VH absent. Vaishnavi SB also absent. Neha S also absent. Okay. You can log out beta. If you have any doubts, you can stay with me. Otherwise, you can log out now.
Thank you, sir.
Thank you, sir.
Sir, can you post a dehydration video?
Oh, bad. Diboration. It's
Yes, sir. Sir, dehydration. So you
dehydration issue.
posted diboration.
Yeah.
So you already posted diboration, but you did
Huh.
not post dehydrogenation.
Dehydrogenation. In which chapter, beta?
Sir, in alcohols.
In alcohols. Dehydration reaction.
Yes, sir.